Hi, I'm Andrew with AJL Mechanical Tips, and today I'm going to go over everything I can think of as it relates to HVAC drains. Let's get started. I'm going to be showing you how to pipe this air handler in a little bit, but before I do that, I wanted to go over the materials we're going to use. And right here I've got regular PVC pipe, and I've got CPVC. PVC pipe comes in different schedules. There's Schedule 20, Schedule 40, and Schedule 80. All relates to the wall thickness, how thick the pipe is, and the pressures that it can handle. We're working on a drain line here, so we're not under actual operating pressure. But even then, I don't use anything under Schedule 40 for piping these air handlers. I consider Schedule 20 like an irrigation pipe or something. And then Schedule 80 would be something that I would probably use when we're getting into a pressurized system, something that's actually, holding water pressure rather than just draining. So basically, schedule is your wall thickness. I recommend 40 for what we're about to do. But also there's ratings on this pipe. This isn't really important when we're running drain lines, but I do think it's something you should know about. On this pipe right here, it says 450 PSI, but it also says at 23 degrees Celsius, which is 73 degrees Fahrenheit. What you need to understand is that this pipe, the pressure rating goes down with the higher the temperature is. So this pipe rated at 450 PSI, at 140 degrees, there's actually a correction factor of 0.5, which means you divide this number in half. So this 450 PSI becomes 225 PSI when it's at 140 degrees. So it's important to know that whatever system you're designing, you want to take into account the operating temperature that the pipe's going to be under. So I found this information on Charlotte's website in their design and engineering guide. There's actually a correction table, and it goes over all the pipe and fittings and the correction factor used. So it basically gives you a multiplier. So basically at 140 degrees, this pipe has a 0.5 correction factor. So you multiply your PSI rating by the correction factor, it gives you the PSI. I want to also note though, fittings have different pressure ratings. This union right here is rated for 150 PSI at 73 degrees. So if this is in your system, this is now your weakest link. So your system pressure shouldn't be under that 150 PSI. And it's different for threaded fittings. This threaded fitting right here has a 240 PSI rating. And at 140 degrees, it drops down to 53 degrees. So just keep that in account. I don't use PVC a lot for pressurized systems. I'm normally going into copper or PEX or something like that, or high density polyethylene fusion stuff for my geothermals. But just keep in mind, if you're doing anything under pressure, you need to look at your weakest link and make sure that meets your design parameters. This is CPVC here. It's very similar to PVC. It's a different kind of glue though, but it's rated for much higher operating temperatures, and it works great for our drain lines on our humidifiers and stuff like that. Now we're going to talk about cleaners, primers, and PVC glues. The first thing I want to talk about is the cleaner here. This is not required for new pipe. This is a product that is basically for going into old construction. If you have an existing plumbing system you're tying into an existing piece of pipe, it has something on it, you can use this to clean it up. If you are doing new construction, new work, and you have a piece of pipe that has some grease or something, it's probably a good idea to clean it with this. Otherwise, a rag normally works. Next thing we have is primer. Primer is used to soften the plastic on PVC pipe in preparation for gluing. It is a requirement on the manufacturer's website. It basically requires that you use primer. If you were on a job running drain lines and let's say you ran out of primer, you would probably be okay, but I'm telling you the right way of doing it, and the right way to do it is to use primer. The next thing we're getting into is glues here. We have regular, medium, and heavy PVC glue, and I'll go over the differences of each, but basically the regular, medium, and heavy has to do with the pipe diameter you're using. This regular PVC cement is rated to 4-inch PVC. So this is going to work for most everything you're going to run in residential. If you step up above that and you need to run something with like 6-inch PVC, you would be going to this medium here. And then if you're doing something really heavy duty, like 12-inch PVC, That's where you get into the heavy duty stuff. And basically, if you need to know this, you can just simply read the back, and it says for all schedules of classes PVC pipe and fittings up to 12 inches. It says there, right there on the top of the can, it shows you what it's used for. Then we're going to get into rain or shine PVC cement. This is used for wet conditions. You know, if you have a pipe that's like on an irrigation system and it's in the ground and you have to dig a hole to get to it and you can't keep it perfectly dry while you're gluing it, this is where this comes in. This is one type of glue that does not require primer. So it's not a requirement at all. You don't have to use primer on it. It even says in the can, primer is not required. I'm not a big fan of this stuff. Using it day to day, I've found that it does take a little longer for the glue to set, and I've been able to actually twist joints back off. So I do use it in weird scenarios where we're in wet, conditions, but I try not to use this stuff if I can help it. Then we're getting into CPVC cement. The only reason I'm showing this is I'm making it clear that there's a difference between CPVC and PVC. You don't want to use PVC glue on CPVC, and you don't want to use CPVC glue on PVC. Two different things. And then this is an all-purpose cement. This is basically for joining two materials together. So let's say you had PVC that you wanted to tie into an existing CPVC line. You can use this to mend the two together. So this works on ABS, CPVC, as well as PVC. I would recommend it only for that changeover joint, though, the PVC into CPVC, and then I would go to whatever glue each corresponding pipe uses. If you're finishing out the PVC, you would then switch to your medium PVC and continue. Now we're going to talk about P-traps and plumbing vents, and I'm also going to go over positive and negative air handler cabinets. Right here to my right, I have a TAM-X air handler. This is made by Trane. And in this specific air handler, the blower motor is located behind the evaporator coil. So your airstream is going this way through the cabinet. Here's your drain line right here that we're going to be piping a drain into. What this means is that this is going to be a positive air handler. The drain line is going to have a positive airflow to it. Whereas this TAM-4 air handler right here, also made by Trane, kind of a different design, has the blower installed in front of the evaporator coil. So the airflow is passing through the cabinet this way. Here's your drain line right here. This is going to have a negative pressure to it. The differences between the two is that this unit here is going to require a P-trap on it to stop us from sucking outside air or to stop us from creating a gurgling noise on our drain or all kinds of things like that without going into a bunch of detail. Whereas this unit here will not require a P-trap, and we normally just come off that unit with a drain line. We go to normally an inline float switch or a clean out of some sort. So after that point, right here we've got a couple P-traps. This is a running trap. This is mainly used for very low profile installs where, let's say, the height of the unit, you couldn't get it up high and you need extra slope, or it's just close. This doesn't have a lot of distance here, so this works in that application. The problem with this is there's very little area for water. So if you're using a system that has a high static pressure, let's say it has a really small duct system on it, so it's sucking really hard, it can actually pull the water out of this trap. And what it'll do is it'll create a gurgling noise. So we typically don't use these. I mean, in a pinch, it might be something we'd use and test and see if it works. But the next thing you can step up to is a P-trap. As you can see, there's a little bit more distance here, so you need a little bit more room for this, but it holds a lot more water and it will resist that negative pressure more. And then my favorite is a float switch J-trap. This is actually my favorite because it solves a couple problems at once. One, you have a J-trap here, which can be used in high static pressure applications, meaning an air handler with a small duct system, very high negative pressure. It will resist that water flow. But it also has a float switch on it, and then it also has a plumbing vent on it. So selecting your P-trap really depends on your static pressure and not your equipment size. You can get a 5-ton unit with low static pressure. That's not selecting your trap sizing. Some people think if it's a 5-ton system, I must need a J-trap, or if it's a 2-ton system, I must need a running trap. It's basically the static pressure of the system. So if you're going to hook up anything other than a J-trap, probably test it and just make sure you're not getting any problems when the blower's in high speed. So now we're going to get into venting. This J-trap here has a plumbing vent built into it. And why do we need a vent? So Right here I have a piece of PETG that I used in water cooling one of my PCs at home just for fun. And basically I'm going to use it to show you what a plumbing vent helps you do. So there's more complexity to plumbing vents, and with multiple P-traps, there's things that can occur without having a vent where you can suck water out of another trap. But to break it down and simplify it, basically, I'm just going to show you, if you have no vent, you see that water was delayed there. It was held back by the pressure in the pipe. So if you have a really long drain line, and let's say a strap breaks somewhere and there's a bow in the pipe, it could actually prevent the unit from draining, or it could create like an area where debris builds up or something. So we put a vent on all of our pipes to where there's none of this going on, and it just guarantees that we're going to have good flow. We're going to talk a little bit about piping design. What I have right here is a Train air handler. This is a convertible air handler. And what that means is it can be installed in any configuration. Right now, it is in a horizontal left-hand configuration. The reason it's horizontal left is because the supply side is on this side, and it's in a horizontal position. If we were to turn this to the right, it'd be a vertical right hand. But basically the word convertible means it can be installed in any orientation. So if I was to flip this and make it a horizontal right, you can see on this Train air handler, there's already a primary and secondary drain outlet for that configuration. The only thing you'd have to do in this specific unit is move a sensor. In other units though, like Carrier and Heil products, stuff like that, sometimes you have to actually take the door off and flip the coil inside the unit and move the drain pan. So right here we have basically the inside. This is the drain pan 4A unit. And I just want to show you that it's important to know that, well, first off, when you flip those coils, you want to read the install instructions and make sure there's no small details, because there might be a special bracket that you have to position in one weird area to put slope on this pan or something. So be real careful when you're flipping those things. But also, as you can see here, there's a primary and secondary outlet here. This primary drain outlet, it has no restriction right here. If you look at this one, there's actually a little slot that restricts water from coming out until it gets to a certain level. We'll go over this more in detail. I just wanted to touch that it's important to know that there is a difference between these two outlets. And even some manufacturers like Goodman, they'll actually put a plastic knockout inside this. That means it won't be able to drain until you remove that knockout. And the reason they do that is because they might have it set up for horizontal left, but you want to make it horizontal right. And instead of having all the drains open, they have them capped off from the factory, and you choose what drain line you're going to use, and then you remove the knockout. So it's important to ensure that that knockout's removed, because if you don't remove it, obviously it's not going to drain. So why do we have multiple drain outlets? Well, the reason for us having two ports here is for a failure event where the primary drain line fails and the condensation needs to go somewhere, and it can either flood out the air handler cabinet or it can leak through the secondary drain outlet. So the setup for this normally works, and I'll actually pipe this and go through it again because you might not fully understand it, but the water is going to come out of this primary drain outlet here, which is basically this drain pan housed inside of this unit. And under normal operation, it's just going to come through that outlet and it's going to drain outside. In the event that it fails, let's say that the P-trap clogs or a clog occurs in the drain line, that water is going to back up. And it's going to back up to the point where the water level rises and starts coming out of the secondary port. Now, you could use a float switch at this port, or you could pipe this drain pipe to go into this drain pan and then have your float switch protection here. So Assurity was polite enough, and this is a division of Diversitech. They provided me with a bunch of switches to go over in this video. And basically, the first one we have here is the CS2. This is a secondary drain outlet switch, and it would basically install right into this port, and it would wire into this air handler. So if this primary drain fails, it's going to back up to the secondary port, and it's going to trip this float switch. So this is the CS2. This is what we call a soft lockout switch, meaning if it tripped and the water level goes back to normal, the unit will go back into normal operation. That's a soft lockout. They also have these switches here. These are hard lockout switches. Basically, it's a latching switch. So it trips once and it locks the unit out. The unit's off. It's not going to come back on. This is good because a lot of times if it's backing into the secondary drain line, there's a problem. Something needs to be flushed. And if it continues to fail and then allow the unit to crank back up and then fail, normally it's when you have like a drain line that's clogged almost all the way. And what will happen is the unit will start running, it'll fill up the drain pan, then it'll shut off, and then the water will drain down. And without having the latching, it would start running again, and you'd create this on, off, on, off, on, off. And you might not know there's a problem. So it runs like that for a while. So they make this standard like this, and then they make a version specifically for train units that has like an extended male adapter here that will go right through this plastic here. So they have that. And then also we have the same thing with our drain pans. So these install in the pan itself. One is a non-latching and one is a latching, hard lockout, soft lockout ordeal. The latching's great. When it fails, it stays failed. And then lastly, we have an inline switch. So I'm going to actually pipe all these and show you how all these are, or I'm going to pipe some of them, but I'm going to show you how all these are actually configured in the system. Now we're going to begin piping our air handler, and I've created a scenario here that you would see on like a new construction or even a retrofit job where I've roughed in a drain line. Let's envision this drain line was installed in the house prior to them sheetrocking, and this is up in the attic now. I've seen a lot of companies are piping 2 drain lines per unit, one for the auxiliary drain pan, one for the air handler. I don't do this. I run 1 drain line per unit, and I ball valve this drain pan. And once I pipe this, it'll be easier to explain why. But in my opinion, you only need 1 drain line per unit. This unit here, we're gonna design our piping in the routes that we're gonna take before we start piping anything. And we're gonna make sure that we're not in the way of any coil doors or any access doors, any filter doors, that we can get to our trap to clean it when we need to and all that good stuff. Like if this unit was installed in a vertical orientation, this would be your drain line outlet. And I've actually seen people come out right here and pipe right over this door, which is your blower access door, and actually gets you into a control panel as well. So the first technician that goes to work on that unit has to cut the drain line out the way and reroute it. When the actual route would have been to come off here, come right out of the coil access door and then route behind the unit or something. So I just want to make it clear that when you're piping, you need to be looking at filters, access service, what's going to be easiest on the tech. You need to be thinking about those things and think about your entire route before you start piping anything. My plan here is this is a positive air handler, so I'm not going to be using the float switch P-trap. I'm going to use a inline float switch, and I'm going to come right off my primary. I'm going to run over here. I'm going to have a T that ties in with a ball valve on this drain pan. This ball valve that's going to go in this drain pan is going to be left to the off position. So the way this works is under normal operation, water is going to come out the primary drain line and drain out of this drain pipe. In the event that this primary drain fails, and let's just say that the secondary float switch that I'm also going to install fails, and it starts flooding this drain pan out, it's going to fill up this drain pan and trip the float switch that I'm going to put in this drain pan, which will then shut down the unit. When a technician comes to work on it, he'll flush out the drain line and fix that problem, and then he'll open this ball valve to drain out this drain pan, vacuum out any residual water, and then close the drain pan back up, or close the ball valve back up. If we don't install a ball valve on the secondary drain pan, what's going to happen is it's going to continue to drain out of this auxiliary drain pan, and it's going to either rust out this drain pan until it ruins their sealing, or it's going to continue flooding the air handler cabinet. And what's going to happen is when they're running their air conditioner, because the whole bottom of this unit is going to be flooded out and running under normal operation, the humidity in the house is going to be much higher. They're not going to know they have a problem. So we put a ball valve on this drain pan so that when this primary drain outlet fails, you know you have a problem. This will all come together once I pipe this together. I just want to explain that I'm designing my scenario before I start any of my piping. In most scenarios, I recommend my installs, we have 2 protection devices, meaning we'll use 2 float switches, whether that be a pan float switch, an inline float switch, or a secondary outlet float switch. We're going to always use a minimum of 2. For this video, I'm going to use all 3 because it doesn't hurt to have all the redundancy. But after 2, it just becomes redundant. You have too much redundancy, and the cost to add a third float switch to every unit is just unreasonable. So we'll normally use a pan float switch. In this case, we're going to use this BG101 pan float switch. That'll go right in here. So that'll be one point of protection. And then I would normally use this CS1 in line on the primary drain line. The reason I use this over the secondary drain outlet is because this also provides me with a clean out right here. So first thing we're gonna do is we're gonna attach a male adapter to this Trane air handler. Never, 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 never glue this fitting. We use Teflon tape, and we put it on the so that when you thread it in, the tape is going the direction of the threading. So this is going to be turning in this way, so I want my tape to end that way, if that makes sense, to where when we thread it in, it's not backing up. But I put about 2 wraps of Teflon tape of this. If it was pressurized, I'd probably do Teflon tape and then pipe thread sealant, but this is non-pressurized, so Teflon tape is plenty. With the Trane air handlers, they have this plastic cutout here, which makes it difficult to get a male adapter in without taking the door off. Sometimes you can get male adapters that don't have this hex on it and they fit right over. You don't have to take the door off. I didn't have one here at the shop. Assurity's made the BG301 Plus, and it has this extended end to it so that it will slide right in without obstruction. This specific fitting, I actually have to take this door off real quick to get it in. So I'd pop that front door off, and I'm going to thread this right here into this primary outlet. Just Teflon tape. Again, do not glue. And then I'm just going to put the door right back on. Well, I'm going to loosen this panel first. So there's our primary drain outlet prep for PVC. What's nice about this is if I had a male adapter that was also like this, I wouldn't have had to take the door off at all. You could just simply thread this on. Of course, this gets Teflon as well. I am not doing it for the purposes of this video. This is our primary outlet. This is our secondary outlet. This is simply just going to get that 301 plus switch right there. If we had a failure, it would not drain out of here. It would fill up and trip this float switch, and it would be a hard lockout. I wanted to mention, if you don't use a secondary inline switch, you should probably pipe your secondary out and pipe it right down into this drain pan here. There's a debate on this. Some people have said that you need a secondary, a P-trap actually on this outlet. I disagree, because during the winter time, that P-trap's going to dry up and it's going to be open anyways. It won't fill up until a failure occurs. So I recommend just piping down like that. So if that fails, it now drains into this drain pan, which will then trip our float switch here. We're going to start gluing our pipe together, and I've got regular clear primer here and purple primer. I personally like the clear over the purple. It seems that I always get the purple everywhere. Just no matter how careful I am, I get it everywhere. I'll use it on one fit in here just to show you what it is. These cans, when they're brand new, they're hard to open. Channel locks is the way for that. You want to get both the fittings. I'm going to grab a rag here. It's always good to lay a rag down with what you're doing. But you'll see, no matter how careful I am, I'm going to get this everywhere. And I'm going to coat the male side. And I'm also going to coat the female side. And I read the directions on this, and it said when it's still wet, apply your PVC cement. So I'm now going to apply PVC cement over this on the female and the male. And then when I insert this, I'm going to give it like a quarter twist as it's going in to make sure that PVC pipe is secured all the way around. I'm going to turn the label into the bottom just because that's an OCD thing that I do. And I'm going to hold it in there for a little bit just, to where I know it's got the fit and tight. 3/4 inch PVC, it's almost instantly glued. If you're doing something like 2 inch or 3 inch PVC, you'll notice you have to really hold that fitting together for about 30 seconds, or it'll actually push itself back out. I got this drain line here, and in this application, I'm going to move on to a CS1 inline float switch. This is a float switch that the pipe goes straight all the way through. You could cap it off in a pinch and use this as your secondary. Let's say that you ran out of secondary float switches on your truck. You could actually use this as a secondary float switch as well, but we're going to use this as our primary drain outlet. And I really like this because this is going to pipe right into here. And when we do maintenances, we can pop the switch right out the top of this. And then we can dump a cleaner down here, and we can also run a brush this way or this way, just using the switch opening. So it makes it real simple from a clean out perspective. So I'm going to add in this float switch here. But I'm in Charleston, South Carolina, and we're in a really high humidity environment. So we insulate the first 15 feet of all of our horizontal runs. I don't believe there's any code requirement on this. In fact, I even looked it up, and there's a regulation for insulating water piping under a certain water temperature, but technically this is a drain pipe. So I couldn't get some clarity on the code, but what I have found is if you insulate 15 feet of your horizontal piping, normally all of the water is warm enough to where it negates any sweating after that point. So 15 foot of Rubatex is what I'm doing. As I'm piping this though, I am planning my Rubatex before I route it. For instance, I need to install this right now, but once I install this, it's gonna be hard. I'll have to split this insulation. So I'm just gonna go ahead and take a guesstimate of how much length I need here. And I'm gonna use these scissors here and cut that right there. I'm just gonna slide that over. So it'll have a clean install now. And I'm gonna glue this fitting on. It is important that you do not glue this float switch assembly in. So I'm gonna stop piping my primary right now, and I'm gonna continue right here on my secondary, because the way I'm gonna do this is I'm gonna actually put a 90 here. I'm gonna put a ball valve here. This will turn, and then I'll get a T here that'll run into here. This will give me the outlet for my primary. So my planning is to get this portion done so that I have something to tap into here. So let's go ahead and pipe that now. So this PVC glue is actually a solvent-based cement. It's actually not glue in anything. It actually has the two materials actually meld together. And it's actually called cold fusion. We're not actually gluing anything. We're just basically causing a reaction that these two materials actually meld together. So I've got my ball valve all piped in here, and it goes to this T right here, and then it continues and goes down. When I was piping this, I almost glued this fitting together, forgetting that this is part of the primary drain line. It needs to be insulated, and it's much easier to slide it on than it is to split it and have to tape it, plus it looks a lot cleaner. This portion of pipe here, it is not going to get water through it most of the time unless there's a drain line failure, because this is going to be in the off position. So it is not necessary to insulate this section of pipe here. We're now going to pipe from our primary over to here, and that will basically be a finished drain line there. I've got this primary drain line here that I need to insulate, and it's going to have a weird fit in here. It's going to have like a 90 here, and it's going to have another 90 below that, which is going to make it really hard for this Rubatex insulation to go over. I try not to split this when I'm insulating drain lines. It just looks better if it's, not split. And so I'm going to slide this on before I glue this joint. But another trick is baby powder. Baby powder makes this process a lot easier. You can actually put it inside of this Ruvertex. And when I go to slide it on this pipe, it'll be much easier to do. So I'm going to bunch this extra insulation up to where I have enough insulation to come up and over my fitting here. This is going to be a really tight fitting, trying to do these 290 so close to each other. So let's just see how this works out. Let that glue set for a little bit. And let's see how this does. Without the baby powder, I probably wouldn't have been able to make this turn. And if I was able to, it would have been pretty difficult. So yeah, that's a finished turn there. All insulated, looks clean. No split insulation, no duct tape, nothing that'll get hot and come off in an attic. So here we have a completed configuration for piping a drain line on a positive flow air handler. I came out this air handler with insulated pipe here. There's no split insulation. I didn't take a turn right here and then come down because that would inhibit the service of the unit. So I actually had to do this weird little S turn here, which I didn't like, but it's more important that we can get to the unit and service it. And I realized when I got to this point that it made more sense for me to pipe this to give me a point to pipe into. So that's when I made that decision there. So from here, there's a lot of other things. This drain line was right by the air handler, so I used 2x4s for my platform. You need to be thinking about drain lines when you're setting up the job, like early on. If this is in an attic and there's no interior wall near the air handler, and the drain pipe that you're going to is 60 feet away that way, you might want to put this air handler on a 2x6 platform, and in some extreme cases, hang the air handler or use 2x8s or something. But 95% of installs, a 2x4 gets your height up there enough to give you enough slope. But the code requirement, at least in my area, could differ in yours, is 2.5-inch pipe and below. You've got to maintain 1/4 inch per foot of slope here. And anything 3-inch or above only requires 1/8 of an inch per foot of slope. But we want to talk about hangers here. This is right in front of the air handler. It's a short drain line. If I didn't put any straps on this, it would maintain slope. It would be okay. But I always recommend putting something on it to give it some rigidness from somebody working up here and potentially bumping it. Somebody's going to work on something else in the attic. He doesn't even do heat and air. He might kick your drain line. So there's a bunch of different ways to strap this. In this scenario here, I would cut 2x4s until I got to the bottom of this drain line here. And I would use a EMT strap, or this is a 2-hole strap, that would go over this pipe and bolt it down to these 2x4s. So this is now like fixed, it won't move. Another thing we have is, you've got this threaded rod hanger. This you'd sink like a Sammy lag in the structure above. A threaded rod would go here and it would hang, the pipe would hang off of this. This is a little extreme, really required for heavier pipes. And plastic strap or vinyl strap or even metal plumbing strap is fine for PVC and stuff like that. And they've got, these split rings can be used. These also have threaded rod in it. This is more used for copper piping, but we've, in weird scenarios, used them. They've got this foot that can be attached. So you could bolt that down, put that split ring in here, and then connect threaded rod in between the two. A little extreme for PVC, but just letting you know it exists. My favorite thing to do, if we have multiple drain lines, like let's say that we have a big house, there's 5 air handlers in the attic, and we came down one chase with, 5 drain lines, and we had 2 DHUs on this job as well. So we have 7 drain lines. Instead of individually strapping every single drain line when we got to the garage level, we would bolt this piece of unistrut up to the structure above, and for every drain line, we would put this strut clamp in it, and it would hang our drain line. So it can hang 7, 10, however many you want, the longer you carry this thing over. And it looks sexy when it's done right and you take your time. That would just slide right over that. This goes over here. And then you can, you 1 drain line, 2 drain line, 3 drain line, 4 drain line. They're awesome. We love them. But that's strapping. Just remember your code is quarter inch per foot. So just make sure you have good slope on the drain. If it goes level for a little bit, it's not a good thing. It will hold water, which will, over the winter time, create a smell and all that stuff and potentially create a clog. It'll still drain, but try to maintain that quarter inch per foot. Also, so I piped all this out and I did 3 float switches on this setup. That's extreme. There's no need for 3. I normally recommend in this application, this pan float switch here, in this this CS1 switch, you just simply pop the top off here and you can clean it out. And then you have your drain protection here as well, which is really nice. And then you've got this other switch, which is a latching switch. So if for any reason, let's say it clogged inside the unit and ended up flooding out the secondary, it would trip this float switch. So the basic operation of this is under normal conditions, this unit's running and draining out of this drain line right here. If the drain line fails, it should trip this float switch and shut this unit down. There's been weird scenarios, and it's normally during construction when there's somebody sawdusting in front of our return air and a bunch of sawdust is getting sucked into our air handler. Wood debris can get in this drain line, and we have seen in the past, not this specific switch, but we've seen switches in the past fail because of wood debris. And in that case, let's say that we don't have this switch in there. In that case, it would fail to this point where it would then, water would then drain out of here into this drain pan. What'll then happen is it'll fill up this drain pan and trip our secondary float switch. And now the unit's off. The customer knows that they don't have air conditioning because they're hot. So a technician would come, he would clear this drain line out here, he'd get it back into normal operation. He would open this ball valve here, it would drain the water out of this drain pan, he would vacuum any residual and close this back up, service call's complete. All right, I know this video is about drain lines, but I can't talk about drain lines without talking about float switch wiring because let's face it, this is the biggest thing during summer that can ruin our summer is dealing with a air handler flooding out a system or something. And it's always something simple that caused it to fail and not fail safely. So right here, I'm showing a typical, this is my float switch right here. And this float switch is my other float switch on my primary drain line. And I can show you an error that people make all the time when they're wiring this. So basically, we have an air handler, and on our air handler, we have our low voltage wiring. And if it's a regular 24 volt system, I'm keeping this uncomplicated, but if it's a standard system, it just operates on 24 volt. And there's a power wire that goes from the red terminal to the thermostat, which is the red terminal. And if we cut that red wire, then we have no power to our thermostat. And if we have no power to our thermostat, then our system's no longer running. So if we use this red as our protection circuit, then we have safely protected the house in the event that one of these float switch trips. One of the common mistakes, though, is that if you're doing dual float switches, it needs to be wired in series wiring, not parallel. So the difference between series wiring is when you run a wire into one device, then you come out of that device, you go to the next device, and then from that device, you go back to your thermostat. So we're running this in series. And if we do it like that, if any one of these float switches trips, it's going to shut the thermostat off. One common mistake made is somebody will parallel wire these, and it's where they take this float switch terminal, they go to red. They take this terminal, they go to red. And then they come to their other side here and go to here. And they come from here and they go to here. So that's parallel wiring. The problem with this is water's coming out of the drain pipe. It trips this float switch. This float switch is now off. So it's now disconnected here. It's not letting power go through the float switch no more. But it didn't shut the unit off because this other float switch is still completing the circuit here. So more than likely, if this occurs, this float switch will also trip. but you have to have both of them tripped for the unit to shut down. So you've basically negated any redundancy that you've created by installing 2 float switches. So if you're new to control wiring, don't worry, I've got you covered. I'll eventually do a controls video. But basically this is your series wiring. We're running from red to the air handler, through the float switch, to the other float switch, and then up to red at the thermostat. Now, an easy way to not mess this up, when you put these float switches in, you can simply connect one wire from one float switch, another wire from the other float switch, connect those together, and you're left with your 2 float switches already in series wiring. So of course, you're going to want to shorten this wiring up and clean it up and find somewhere to zip tie it and make it look good. Remember, quality is your reputation. You want it to look good for the homeowner. Lastly, I need to mention that some manufacturers have a specific terminal for float switches. This train unit here, it actually has a terminal designated for float switches. And the reason for this is when the float switch trips, instead of just shutting off the thermostat, it'll actually report an error code and it will send out an email to the customer letting them know that their thermostat's down. The biggest issue I have with these is that you have to enable these float switch terminals at the thermostat. So if you wire into it and then forget to enable that, that feature, you also have no protection. And that goes back to why testing is so important, because at the end of this, I'm going to show you how to test all of this and make sure it's functioning properly. So I've repiped this drain line using a float switch J-trap here. This air handler is positive pressure. It doesn't normally use a float switch J-trap. The only reason I'm doing it is for the purposes of this video. But basically, this is the setup you'd be looking at. It'd be very similar. You've got your primary drain line, goes in your float switch J-trap. That's going to run into my main drain line going outside, and my auxiliary pan piped in the same way here. This would all be insulated. I just didn't insulate it for the purposes of this video. I've already shown you how to do it. I don't need to do it again. But I've also got a condensate pump here, and I'm basically showing you that, if you're in a garage, you don't have enough slope. You have a garage, you want to get it outside without running the drain line in front of where they're parking their cars. You would use something like a condensate pump. The configuration at the air handler is completely the same. This is just your exit point would be a condensate pump. Condensate pumps are actually also really helpful in scenarios when you have a nuisance drain line. That's a drain line that we get clogged 3 times over one summer or something, just continually clogs. Maybe some other company installed it. We can't access it no more because all of the drain's in the walls and it's a finished house. We've come and put in condensate pumps and solved some of those problems, but we try to avoid them when we can because it is another point of failure. This pump can fail. There's also a float switch in it, so it will fail safely, but it's just another component that can fail, so we try to avoid it. Also, so this is a pre-configured float switch P-trap here. This is my vent right here. So remember, we use a vent to stop this from occurring. That's what the vent's for right there. If you get a regular J-trap that doesn't have this float switch part of it, you'll have to add the vent yourself, which you just put in a T, and then, no, not right now. Then you would add this piece of PVC here. And what's important here is this J-trap comes right off the unit, but let's say that you mounted this PVC over and then down, and you put your J-trap low or something like this. You want to make sure that this vent is routed higher than your outlet portion of your air handler. The reason being is if a drain line clogs further down and it backfeeds, it will actually flood out of this port before it trips a float switch that you might have on this end. So make sure that the vent is just higher than your primary outlet point. The only exception to this is if you're doing a rooftop package unit. If you're doing a rooftop package unit, you want to keep this vent really low. And the reason being is a rooftop package unit's not going to have any kind of condensate overflow protection. And if the drain backs up, you want it to flood out of the vent versus flooding inside the building. I'm going to show you a couple methods here to clean a drain line out. There's a bunch of different methods. This is a float switch J-trap, float switch J-trap. It comes with a cleaning brush here. And this is one of the simplest methods. 90% of the time, your clogs are going to occur at this J-trap because that's where it's holding water, and debris actually accumulates right there as well. The J-trap's necessary, but that's one of the downfalls to it. And to clean this out, we simply remove the float switch right here, and we remove this cap right here. And I like to put this drain brush in backwards like that, And then I'll grab a rag and I'll pull this drain brush through this drain line. But when I get to the top here, I'm going to wrap it with this rag and catch all the debris coming out so it doesn't make a mess in the attic. And then I'll treat it with chemical and run the brush through a couple more times and make sure it's filled up at the end. And if that's the only clog, then I'm done. You can also pop this right here. If you pop that cap, it allows you to run the brush in this way. And you're now getting into the evaporator coil section as well in case any debris is caught up at this end. During maintenances, aside from brushing this, we will also come and add chemical. This is what we just call blue water. And really all it is any HVAC treatment tablet. This is a Surety Pro Treat tablets. And we'll add it to a jug of water with and shake it up. And basically we'll use this as our cleaner. Another thing we'll commonly use is evaporator coil cleaner because we always have it on our truck. Don't want to use condenser coil cleaner. There's a lot more chemical in that and it's just not really safe. But the evaporator stuff's designed to go into drain lines already, so we use it. But with the chemical stuff, we'll pop the float switch off, put a funnel in right here. We'll fill up our drain line. And then we'll let some of that go down the drain and we'll continue our maintenance. We'll actually clean the coil and check the blower and check our amp jaws and everything, do our complete maintenance. And then we'll go back outside and when we're doing our maintenance on the condenser coil, we'll then use a wet dry vac to suck everything out of the drain line. So with the shop vac, we filled up the drain line and we'd go actually outside. And this is just a regular small shop vac. And I've taken electrical tape and rigged a piece of PVC going into it. And normally the drain lines coming out the house, they're angled down and they're going close to the ground. So it's really hard to get this hose to it. So you simply just rig up this fit and hook the wet dry vac up to it and give it power and just suck everything out of the drain line. You can also do this inside at the J-trap, but if you're not having an active drain line issue, then it's just maintenance, just to dump chemical in it, make sure it's clear and vacuum it out outside. The biggest part about this is you want to make sure that you come back inside and prime this trap before you leave. And we always make sure that the unit's draining before we leave the house. Another method we have is pressurized air. We used to use this with dry nitrogen tanks. We had a rubber stop on the end. This one's a little large, but they were smaller ones that would actually fit in drain lines. The problem is you're carrying this big tank into an attic. You need to set your pressure real low because it could actually blow the drain line apart. This isn't just really it's just not really recommended. There's tools that have been released, and Diversitech has this swoosh gun here. This is a single cartridge gun that holds a CO2 cartridge. They also make this it's a double cartridge swoosh gun, and all you do is simply load up some cartridges here. And I'm basically loaded. So carrying this big thing into the attic versus carrying this, and this is a much lower, safer pressure. And then you would basically just take this, you would push it past this point. You want to get it down to here so that you're not also pushing air into this drain line. And you would squeeze this trigger, which would blow through this J-trap. I recommend removing this, putting a rag on the top or something, because when you blow it out, it's going to discharge all that stuff into the air. But as you can see, this thing really puts out some pressure. I want to note with the pressurized methods, if we see rain or shine glue on the PVC, we normally don't use any pressure on it because we have seen the piping blow apart with this stuff. It just, I don't know, it just doesn't glue apart. It doesn't glue together as well as some other PVC cements. So we normally go into the pressurized stuff after the wet dry method and the chemical method has failed. Now, if you wake up in the middle of the night, it's like 10 o'clock at night, and you're hot and bothered, your thermostat display's off, it's because your drain line's probably clogged. And sometimes you might not have a brush or chemical treatment or a gallo gun or something. You might have something like this, like vinyl hose, or you might have a straw in your kitchen or something. We're talking about just getting you through the night to the next morning. So you can simply take a vinyl hose like this and insert it in here. not only can you use this as a brush, but you can blow with your mouse and pressurize that drain line. You might not completely clear it, but you might get it clear enough to where the float switch releases and you can sleep through the night. Lastly, if you have troubled drains that are just clogging constantly and you can't rerun the drain for whatever reason, it might be a good idea, depending on if it's not set up like this where it has an easily accessible port, you can easily add a union to that. And what you can also do with troubled drain lines is you install a condensate pump and you would pipe a new drain to that condensate pump, and then your drain line tubing would be glued into your PVC. And that way your unit now fills up the condensate pump and then it pressurizes your drain line every time it runs, and it will probably solve your nuisance drain problem. But we strongly recommend you only add condensate pumps when they're needed, when you don't have slope or when you have a troubled drain line, because it's just one more point of failure and it's one more thing that you have to float switch. Last thing I'm going to discuss is testing. And testing is one of those things that it's always happening at the end of the day. And there's things that are easily missed. You know, you've gone to a job, you've pulled the whole air handler out, you've put a whole new air handler in, you've soldered it in, you've done all this work. It's 6 o'clock at night, it's hot, you've been sweating all day, you're not thinking clearly because you're hungry. And you have to test all of this after it's been running. It's extremely important. And what we're gonna do is we're gonna fire this system up, we're gonna let it run for a little while, and we're gonna test our float switches each individually. We're going to trip this float switch by manually leaning it up. That will trip the pan float switch. If it's wired to this train air handler, it's going to give us an error code. If it's wired to a regular 24-volt system, it's going to shut the display off at the thermostat. So I would trip that float switch, then I would release it, and then I would move on to this float switch. I would trip this float switch, then I would release it. And then if I had a condensate pump in here, I'd also pop the top off. I would trip the float switch in here and make sure that the indicator light went to alarm and that the system also shut off. And then it's important that you prime your P-trap before you leave. And then the biggest thing is to walk outside and actually physically see that water coming out of the drain line. If you're not sure what drain line it is, you can use this blue water, the tablets that I use, and you just simply dump it down the drain line. The blue water will show up outside. That way you know you've got the right system. And just make sure everything's running and you have a happy customer on your way out the door. The worst thing would be that you drive home and you get about, you get 3 hours in after you're showered and all, and then you get a phone call from your homeowner complaining about water being in their ceiling. Trust me, that's going to be much worse than you hanging out for 15 minutes and testing everything on the system out. I'm going to show you one scenario that will happen often, and it's when you have to come and add a dehumidifier or add some form of appliance after the job is complete. And you only ran the one drain line for your specific unit. So if it's new construction and you have a dehumidifier and an air handler, you want to run one drain line for that dehumidifier and one drain line for that air handler. But if you have to come back and add a dehumidifier for whatever reason, let's say they add an aquarium or whatever, they do something weird and they change their house, you now need a dehumidifier. You can absolutely tie your drain lines together. A 3/4 drain line will handle a ton of condensate, but the problem becomes protecting the condensate from overflow. In this scenario here, let's say that we installed this dehumidifier and it was suspended from the roof rafters above, because we typically will suspend dehumidifiers. They have a compressor, they vibrate, so we suspend them. So let's just say it's higher than this air handler. And let's say that we piped it into this air handler right here, and there's a drain line clog that occurs right here. So if we don't add additional protection to this, what will happen is this drain line will back up and this air in the water will back up to this point. It'll trip the float switch of the air handler. The air handler will shut down. That's great. Air handler's off. But the problem is this dehumidifier does not know that this occurred, and it's going to continue running, and that water is going to backfeed and continue flowing out of this drain pan, flood the sealant out, and now you've got a sealant that you have to pay for to repair. Or you can just simply take and add a second float switch to your air handler right here in this drain pan, and then this will wire up to that dehu. So what happens is the drain line clogs here, water backs up, comes up here, trips the air handler float switch, shuts down the air handler, and then it trips the float switch for the dehu and also shuts down the dehu. That's one solution to that. There's nothing wrong with that solution, but you need to, whenever you configure this and install it, you need to step back from it when you're done and look at your protections and make sure that they make sense. A couple tips for you. I strongly recommend not dry fitting your fittings. That's basically where you pre-fit everything together and then come back and glue it. I found that most of the time when this occurs, glue joints missed and failure occurs. So I haven't needed to dry fit it. There might be one weird scenario where you have to do something, but try not to make it a habit of dry fitting these all together. It's just another point of failure. Baby powder. Baby powder works great inside Rubitex insulation. And when you're going to run this over, curves and turns and all, baby powder makes it much easier. It won't split when it's making a turn. That's kind of one of the biggest tricks I found. And then also, if you have troublesome nuisance drain line failures, meaning they continue to clog, a condensate pump is a good solution to that. Try to avoid it whenever possible. But if you have a drain line that you're going out to 3 times in one summer, put a condensate pump on it. The problem will be solved. And then lastly, test. I can't stress this enough. You need to test your float switches. You need to make sure the water's draining outside. You need to make sure everything's running before you leave. This is the worst thing that can happen, is flooding out someone's system, because they're not only losing air conditioning, but now they have damage at their house to repair. If you enjoyed this video, hit the like and subscribe button. Stick around for more content. I'm Andrew with AGL Mechanical Tips, and remember, quality is your reputation.